Hello, Year 9. So in today's lesson, we are going to still be discussing this big question. How do computers use algorithms? That is just sets of instructions to sort and search for data. Today, we're going to talk about a sorting algorithm called the bubble sort and how that actually works to arrange data in a certain order. Now, previously in this unit, we've talked about computational thinking, where we talked about abstraction and how that's all about taking away unnecessary information from a problem, just to focus on the stuff that is actually necessary, is actually going to be uh, useful to help us to solve a problem. We talked about decomposition and how that's breaking a big problem down into sub problems or just little problems that just make it easier to solve the whole problem in the first place. And algorithmic thinking. So once we've broken our problem down, well, what order do we need to do those steps in to actually solve the thing that we wanted to solve? We then talked about searching algorithms and how there are two searching algorithms. One, a linear search, and two, a binary search. Now, a linear search is brilliant because the list that we're looking through doesn't have to be in order, but all it does is look at one item at a time in that list and just compare it to the thing that you're looking for. So if your item is at the end of the list, it's going to have to go through each one of those items in order from the first one to the last one to find the thing that we're looking for. Binary search, however, is much better. It's more of a control or a smarter way to search through data. It's where you get a big list, and through each examination, each comparison, you're comparing the middle item, which means that you can halve the list every time you're searching. But the problem is the list needs to be in order already. And that's where sorting algorithms come in. And there are three sorting algorithms that we're going to be talking about and learning about. In today's lesson, we're going to look at bubble sort, which by far and away is the simplest algorithm, but also the slowest. Insertion sort is sort of in the middle. Merge sort, definitely the most complicated algorithm, as it were, but super, super fast. Today, the bubble sort. If you're going to be looking at a list and trying to find a surname, I think we all need to be in agreement. Actually, the list that is sorted in alphabetical order is just going to be easier to search in. It just makes sense, right? If it's all randomized, like list one is, it's just difficult to find anything. You've literally got to go through each one of those surnames to find the one that it is that you're looking for. Sorting is really important. Humans, we categorize things all the time just to make it easier for us to figure out where things are. We do it in supermarkets, and it's just usually done to make searching for things just a lot faster. So let's say that we have a list of books. One set of books are in alphabetical order, the other isn't. And if you're searching for a specific book, you'd want to search in the book that is already alphabetized, one that's already sorted. A sorted list is just easier to search in. Why? It's because it's easier and faster to locate the items that we are searching for. Thankfully, we've got computer programs that can do this job for us to make our life just a lot easier. The first of which is a bubble sort. Now, a bubble sort, like I said, is probably the slowest algorithm, and it takes us a long time to actually do. And we are going to be performing the bubble sort algorithm in today's lesson. But it is super simple to sort of understand. It basically works by repeatedly going through a list and comparing items that are next to each other. And if they're in the wrong order, you just swap them over. Each time you go through the list, it's called a pass. And more than likely, with a bubble sort, you're going to need multiple passes through a list of items to get it into order. So let's say that we had this set of numbers, right? Underneath each one of those cups is a number, and you're going to see them in just a moment. Here they are. They're not in order, but we are going to use the bubble sort to put them in order. And this is how it works. First, you're going to look at the first two pairs. Sorry, the first two numbers, the first pair. You're going to look at what's in them. And what you're going to do is figure out whether or not they're in the right order. And if they're not in the right order, you are going to swap them around. You then just move on to the next pair. So leave the first one, on to the next, and we can see that those two are also not in order. So we swap them over. Then we move on to the next. We can see that these are in order. So in actual fact, we don't need to swap them. We just leave them as they are and move on to the next pair. This continues happening over and over and over again until we get to here. Now, one thing's for certain, those numbers aren't in order yet. But there is one number that is in order. There is one number that is in the right place. After one pass of this bubble sort, the largest item bubbles its way to the end, or the top, which is why it's called a bubble sort. The largest item, which is number 80, has managed to get its way all the way to the end and is now in the right place. So after one pass, we're not saying they're in order, but the last number is. Which means that in the next pass that we do, the second highest number is going to bubble up to the top. Then the third pass will be the third highest number, and so on and so on. Like I said, this algorithm is really, really simple, but it is just really long. So when we're doing it, and when you see it in exams, what you're actually going to find is that you get asked for what the next pass is going to look like. We're going to have a go at those in our tasks in just a moment, but I want to talk to you about what that actually means. I'm going to show you here what the next pass is going to look like, and I'm going to show you instantly how to do it without doing any of the swapping nonsense. So, first thing we do is compare 21 and 2. What I'm going to do then is write the lowest number down out of the two. There you go, number 2 is. I'm then going to delete that from my list. I'm going to compare the next two, which is 21 and 43. I'm going to write the lowest number down, which is 21, into this position here. Cancel that from the list, and then move on to the next item, or the next pair, which is 43 and 3. I'm going to write 3 in this position. There you go. Cancel it from there. And now I'm going to compare 43 and 50. 43 gets moved into this position because it's the lower number. 50 and 35. So 35 gets moved here. Cancel that from the list. 50 and 64. Well, 50 gets written in this position. Cancelled out. 64 and 7. So 7's here, which means that 64 and 80 get compared. We know that 64 needs to go here, and 80 keeps its place over here. Notice how in that second pass, which is what we've just done here, the second largest item, which is 64, has bubbled its way to the correct position. That's an easy way to show what the next pass is going to do. Now, there's one last thing that we need to discuss about the bubble sort, and that is how does the computer, or how does the algorithm, how does the set of instructions know that that list is in order before it stops working? Well, what you have to do is complete a final pass after you know that they're in order. Problem is, we're human, we can see the entire list, but computers can't. They're just comparing those items, right? So if in a pass no swaps are made, then that means that the elements, the numbers, are in the right order. So the algorithm can stop executing. So that bit in bold that's there, what we're going to do is keep repeating those steps until no swaps are made. We're going to compare those pairs, and if no swaps are made as we go through from the first to the last, then we know that those items, those numbers, must be in order.